Acceleration of free fall using a pendulum. Figure 1.1 shows the pendulum, and figure 1.2 shows that one complete oscillation or one complete vibration. On a figure, measure a distance d. So using a ruler, you will measure this distance. So I will take an approximate value because we cannot measure on the soft copy. So example 5 centimeter. Then the next part, figure 1.1 is drawn 1/10 of the actual size. So figure size is 1/10 of the actual size. What will be the actual size if d is equals to, according to figure, if actual d is equals to 5 centimeter? So actually how much it will be? What will be the actual value of the d? So it will be 10 times. So if this was 5, so 10 times this will be 50 centimeter. The student displaces the bob slightly and release so that it's swing. He measures the time for 10 oscillations. The time is time t is shown in the stopwatch. This is the time for 10 oscillation. Write down the time t shown in figure 1.3. So what is this time? The time interval. 14.06, because 14 second and there is also 06, so it's 14.06 seconds. Then calculate the time, calculate the period, the time period for one oscillation. So this is a time for 10 oscillations. How to get the time for one oscillation? This 14.06 seconds is the time for 10 vibrations. So if we need for one, then we'll divide by the number of the vibration, that is 1.406, and because you have two decimal places, so 1.406, it means that will be 1.41. The next part, calculate t square. So value of the t was 1.41. What will be the value of the t square? Means 1.41 square. 1.98, and that is second square because this was second, so square, this will be second square. Then calculate the acceleration of a free fall g, which is 20 divided by t square. So 20 divided by t square, g is equals to 20 divided by t square. The value of the t square is 1.98 or 1.99. Okay, 1.9881, so it means 1.99. So the answer is 10.1, and the unit meter per second square or Newton per meter, Newton per kilogram. Yeah, 10.05. So this will be rounded off to 10.1. Then in part C, student adjusted the pendulum until the distance d measured from a center of the bob is 100 centimeter. He repeated the procedure for t square. He's getting 3.94. On the dotted line above, the write the unit for t square. So what will be the unit of t square? So it will be secant square. Then calculate the acceleration of a free fall using a formula g is equals to 40 divided by t square. So g is equals to 40 divided by t square, which is 3.94. So 40 divided by 3.94, what is the answer? 10.2 meter per second square. Then part D and E, another student states that repeating the experiment improved the reliability of the value of the G. Suggest two changes that would make to improve the reliability, and stopwatch cannot be changed. So basically what we are doing in this experiment, we are measuring a time for oscillation, we are measuring a time period, and we are measuring a distance. These are the two factors which we are measuring. So how we can change? The question is, suggest two changes that you would make to improve the reliability. Repeating experiment, already they mentioned that another student said that repeating experiment improve the reliability. That's true. But the question is, suggest two changes that you would make, means what two changes you will make so that you improve the reliability. So adjust the distance where the bob is released. That's like use more values of D, or this term add more values of a D. That's the same thing. And increase the number of the oscillation, because these are the two things which you are increase the time period. Actually the time period will remain same, but you record the value for more oscillation. Like here you recorded the time for 10 oscillations. So instead of recording the time for 10 oscillation or 10 vibration, now you will record the time for 20 vibration, because 20 vibration, the percentage error will be smaller. Why? Percentage error is equals to the smallest value, the least count, divided by the value recorded multiplied by 100. So if you record a greater value, the percentage error will be reduced. That's why you will use more vibration, record the time for more vibration, or adjust the fixed distance where the bob should be released, or add more values of a D, or use different values of a D. Yeah, make sure that external factor of force does not affect, that is there. But the thing is, they're asking two changes, like suggest what two changes we should do to improve the reliability of the result. Like example, if I say I'm repeating the experiment, student record the time for 10 first he fix, like he use this distance and he record the time for 10 oscillations. How he can make sure, how he can improve the experimental accuracy? So he should repeat. And how he will repeat the experiment? By recording a time for different oscillation, like different number of oscillation, or repeating the experiment with different lengths. Is it clear? Marking a mean position and extreme position, why it is not given here as an answer? Because in the question they're asking two changes we will make to improve the reliability, like two changes we carry out so that the result will be more reliable. Like how we can repeat the experiment. Make marking a mean position and extreme position will improve the experimental accuracy, but it's not repetition, so it is not improving the reliability. Reliability of the result increases as the repetition is done. Suggest one precaution that you would make in the experiment to obtain the readings obtained are accurate as possible. So how we can make sure the readings are accurate as possible? In this one, you should avoid a parallax error, look perpendicular, reset the stopwatch, measure the distance from the center of the bob. In this one, you should mark a fiducial point like mark mean and extreme position. Is it clear? Discussion? The second question, a student, yeah, that's right. In the beginning, the box should be stationary. A student is investigating the resistance. She uses the circuit shown in figure 2.1. She measures the potential V1 across R1 and the current in the circuit. Figure 2.2 and 2.3 shows the voltmeter and ammeter reading. Write down the reading of voltmeter and ammeter. What is the reading of voltmeter first? And what is the reading of ammeter? As you can see, between 0 and 1, there 5 lines are there, so each is representing 0.2. So voltmeter reading is 2.2 volts. And ammeter reading between, because when you check the numbers, each value is 0.02, so 0.42, 0.44, 0.46. So that will be 0.46 amp or ampere. Calculate the value of the resistance R1. So what is the value of the resistance using the result 2.2 and 4.6? When you divide them, what is the answer for R1? 4.8. Because the two decimal places, so 4.78 ohms. The next part, student suggested that a student measure the potential difference across each resistor, and she calculated the resistance of each part. She records the value R2 was 4.75 and R3 is 4.81. State whether the result suggests that three resistors have the same value and justify the statement by reference to the result. Are the values same? How we can work out? We can calculate the percentage difference. So what is the formula for percentage difference? It is the maximum value divided by minus minimum value divided by mean, the average, into 100. So maximum value in the combination is 4.81. The minimum value in the combination is 4.75. Divided by mean or average. What is the average of these two numbers? 4.81 plus 4.75 divided by 2. The average 4.77. 78. Okay. 4.78 and then into 100. What's the answer for percentage difference? Maximum minus minimum divided by mean into 100. So that's the percentage difference is only 1.23%, which is less than 10. So statement will say yes, and justification with respect to, so percentage difference is less than 10%. So within limit of experimental accuracy, R1, R2 and R3 are same or equal. Calculate the combined resistance R1, R2 and R3. They are connected in series, and the formula to calculate the combined resistance is R1 plus R2 plus R3, and give your answer to suitable number of significant figure. So R1 was 4.78, R2 is 4.75 and R3 is 4.81. What is the value for R, the combined resistance of these three resistors? 14.3. So 14.3 ohms. Then student check her result by connecting a voltmeter across all three uh, resistors connected in series. Take a potential reading would expect to be closest to the reading she obtained. Like student, what she did now, she connects a voltmeter across this series combination. The voltage here was V1. Voltage across R1 was V1. So the question is, what will be the reading on voltmeter? As we know, they have equal resistance, so equal voltage will divide. The voltage will divide equally. So what will be the reading on the voltmeter? So which part is correct? Use screen annotation for this. Just take the one which is the right option. Yeah, so it will be 3 times V1 because voltage across one resistor is V1 and there are three resistors in series. In the question, they mention a student check her result by connecting a voltmeter across all three resistors in series. Take a potential difference reading you expect to be closest to the reading she obtained. So when she connect a voltmeter across the three combination, the voltmeter reading here was V1 because all are same resistance. So voltmeter reading here also V1 and this one also V1. So what this voltmeter reading will be there when which is across all three. So it will record 3 times V1. Like if this was 2 volts, here also 2 volts, here also 2 volts. So voltmeter will record 6 volts. The next question, complete the circuit diagram in figure 2.4 to show three resistors connected in parallel, voltmeter to measure voltage across the resistor and variable resistor to control the current in all three. So you can use a screen annotation to draw, or you can also use any other part of the screen to draw your circuit. It is not necessary that you use the same space. You can draw your own circuit. A variable resistor should also be there which changes the current in all three resistors altogether. Three resistors in parallel, a voltmeter to measure the voltage across the resistor, and a variable resistor which is used to control the current or change the current in the three resistors. There should be a variable resistor as well. which is used to change the current in the three resistors. But the circuit symbol here, look, one thing which is important is the correct circuit symbol. As I mentioned, three resistor, so you should use the circuit symbol for resistor. This is not the correct position, Hashim, because if you connect variable resistor parallel, so it will not be useful. You want to change the current, so the correct one, when you draw this circuit, if you connect a variable resistor at this point, so this variable resistor only change the current in these two, so this will not be effective. So three resistors connected in parallel, a variable resistor and a voltmeter. The voltmeter we attach here measure only the voltage across. Basically, the voltmeter, if we connect a voltmeter here, because the voltmeter connected to measure potential across the resistor. So this voltmeter will measure the voltage across, they all are in parallel. So it will measure the voltage in these all three resistors, because they will have the same resistor, they will have the same voltage as they are in parallel. Like if it's a 10 volt supply, 7 volts drop here. So the remaining 3 volts will be here, and that 3 volt across each resistor. Then next question, a student is determining the focal length of a lens. Figure 3.1 shows the apparatus. The student placed the screen at a distance of 70 centimeter from illuminated object. So this total distance is 70 centimeter. He places the lens close to a screen and moves the lens slowly away from the screen until a well-focused image is formed on the screen. He measured the distance u. U is the distance between the object and the lens, and v is the distance between lens and the screen, the image. And you can clearly see that the object distance is smaller and image distance is greater. So this will form an inverted, and larger, the image will be larger than the object. He measured the distance u and v. He repeated the procedure with distance d. What is d? D is the distance between the screen and the illuminated object, means this. So he repeated with 75, 80, 85 and 90. The readings are shown in the table. Calculate and record in table 3.1 u multiplied by v for each value of d. So you have to u multiplied by v. Just the value of u multiplied by v. Use the screen annotation to complete this table. U multiplied by v. You can write it any other part as well, because only one box is available. So you can write answer here or beside it. One thing you should keep in mind is the number of the significant figure which you use for your answers. All should be in same number of significant figures in the table. So when you check, like example, the first value I'm getting 1060 and the second value is 1128.2. So this one I'm having 4 significant figure, the other one 5. but I should have equal number of significant figure in one column. It's not like all the columns should have same number. In each column, the number of the significant figure should be same. So I should round it off this to 1128. Then this will be 1200, 1283 and 1353. It is 1352.8, but because I'm using 4 significant figure in this column, that's why I should use same number. Like I should round off to 4 significant figures. The next part, using the result, you have to sketch a graph. So plot a graph for V multiplied by U multiplied by V, which is centimeter square against D. This should be on y-axis and the other one is on x-axis. You do not need to start your axis from origin. So first thing, we should check the value of U into V. The first value of U into V was 1060 and the last value was 1353. In between are there the values 1283, 1200, 1128. So smallest value is about 1060 and the highest one is 1353. So I have to select a scale so that it's like from 1000 to 1400. So if I start my scale with this value as 1000, 1100, 1200, 1300, 1400. That is the value for U multiplied by V, which is centimeter square. You should label the axis as well. And for x-axis, we need D. When you check the value of the D's smallest value is 70 and the highest is 90. So I have to select my scale between 70 and 90. I have to take the values on the axis. So example, if I select this as 70, after 20 boxes, I took that as 80. And after further 20 boxes, I took that as 90. So when you plot the result, approximately like, because it's the values when it is 70, it was 1060. And the last value was when you multiplied 17 by 19 by 71.2. What was the last value? It was 1353, I think. Yeah, and this value was 1060. So I'm just sketching a graph. I'm not plotting the graph. I'm just sketching, like showing the possible shape. So the first value, when it is 70, it is 1060. Each box is representing 10. And the last one, when it is 90, it is 1353. 1353. So possible when you sketch, when you plot the graph, because not sketch, I'm sketching, I'm just working out the value, so it will be like this. In between the results will be there. You will try to draw a best fit straight line. Then using the graph, you'll find the gradient. How to find the gradient? Take any 2 points. The distance between the 2 points should be 5 centimeter for accurate answer. So first value on x-axis is x1. The second value on x-axis will be x2. The first value on the y-axis will be y1 and the second value will be y2. And you will use the formula y2 minus y1 over x2 minus x1 to find the gradient of this graph. You have to show these points, the points which you are taking, you have to show on your graph. The focal length of a lens is numerically equal to the gradient. Like example, what is the value of the gradient? That is equals to the focal length. So if I'm getting a gradient example, I'm getting a gradient at 14.5. So focal length will also be 14.5 centimeter. Student suggests two difficulties in this experiment when trying to obtain an accurate reading. This is a lens experiment. We discussed this earlier as well in the papers, the past papers. So what are the practical difficulties? Because we are measuring the length, so as we are measuring a length, so we have to measure a length from the center of the lens. So first problem is measuring or finding the center of the lens. That's the first thing, difficulty, practical difficulty. Then forming a sharp image on the screen, that is also another possible practical difficulty, because practically the image will be dim. Normally the image which is formed is faint or dim, so it's not easy to recognize when we have a sharp. So finding the exact place where the clear image is formed, that is a practical difficulty. Measuring the height of image, your ruler, or that can also be a possible. But in this question, because we are not measuring the height, this is right. This is a practical difficulty, that measuring the height of image, because the ruler or the hand may obstruct the formed image. That's true. But in this case, because we are not measuring the image, that's why it's not valid here according to this part. It is right, this is true, that it is difficult to measure the size of the image because our hand or a ruler will obstruct the image form. But according to the experiment, it's not valid. Why? Because we are not measuring the image, we are measuring the distances only. So anything which leads to a difficulty in measurement of the distance, that is acceptable. The last question, a student is investigating the effect of double walled insulation on the rate of a cooling. Like double walled insulation means two walls separating the two surfaces from each other. Like two surfaces are separated from each other by some distance. We call that a double walled insulation. Student placed a copper container inside a large metal container. So how he made this? He take a large container, and inside this large container he placed a copper cup. So when he placed this copper cup, this is called a double wall insulation. Plan an experiment to investigate the effect of size of air gap between the copper container and the large metal container, or a rate of the cooling. So how we can plan this experiment? First thing, how would you carry out the investigation? So how we will carry out this investigation? We will fill the copper cup with hot water, or we will place copper cup inside large container, and measure the distance of the gap. So we'll measure the gap by a ruler, and then we will add hot water record its temperature for t- for 30-second interval, we till 3 minutes or 180 seconds. Then we will repeat the procedure. Different cups or different size cups. That is the procedure. State the key variable you will control. What are the factors you will control for a fair comparison? The key variables. The time for same volume of the water, same time interval, same room temperature, same initial temperature, that's two. So same volume, that is one. Initial temperature of the water, that's another. Room temperature, because room temperature also affects the rate of the cooling. Same room temperature should be there. Surrounding condition, air current should be same, like in the same environment it should be done. Same time interval. Then draw a table or tables with a column heading. So what we will do, table or tables, like example, cup size A. So this one will be the time, which is in second. Then temperature will be there for cup A. Then temperature is there for cup B. Or you can make a separate table. Yes, we will use the thermometer. I forgot to put a thermometer. Here I mentioned record temperature. So we record the temperature by the help of thermometer. No need to, if you are using a lid, so it should be for all the, because you are investigating the effect of the insulation, so there should be a lid as well. All should have or covered with a lid so that they will not lose energy due to evaporation or convection. Explain how would you use your result to reach a conclusion. So how we can reach our conclusion, we can plot a graph between time on x-axis and temperature on y-axis, and the one which is having a steeper slope, the one which will have a steeper slope will have a faster rate of cooling. But you don't have to plot a graph, but how you reach your conclusion, uh, we'll plot graph and compare the slope, steeper slope, faster cooling. Is it clear? Yeah, we can also use the change in the temperature, the one which will show a small change in temperature, that is a better insulator, or the one which show a greater change in temperature, that will have a faster rate of cooling. Is it clear, this experiment? So solve this paper and send it now. Or you can send anytime in the evening.